and it's my pleasure to invite Dr. Rajashekhar Malur, Chief Technology Officer, Tata Consulting Engineers. His responsibilities include enabling Industry 4.0 and IIoT-based solutions across the energy, process, and infrastructure verticals. He joined TCE in 1994 and worked on Tarapur Atomic Power Plants, Unit 3 and 4. He obtained his PhD from IIT Kanpur 1994, during which he was a visiting scholar at the Johns Hopkins University, Baltimore, Maryland, USA. Please welcome him on the stage.
Good morning, and let me thank ARC Advisory for giving me this opportunity to speak in front of all of you. So I'm going to talk about a wide range of applications from an Indian perspective, and some of them is something that we have already executed, and some of the examples that you will see are something that is currently underway, and you may also see a couple of them which are in the idea stage. In the final presentation that I will share with ARC Advisory for sharing with all of you, I may have to sensitize a little bit. And so if any of you need any details, my email ID is out there. I will start by introducing a little bit of the company. I don't think Tata Group needs any introduction. We are there for 150 plus years, and Tata Consulting Engineers per se began in 1962, and some of the names you may be familiar with. Dr. Setna, who is the Atomic Energy Commission chairman during the India's first nuclear test way back in 1974, was also our first chairman. Those of you who have heard Tata Sumo know about Sumant Mulgaonkar, on whom it is named. And so we inherit a part of the group's heritage. So we are basically into three verticals: infrastructure, resources, and power. In infrastructure, we are very strong in water, be it Bangalore, Delhi, Hyderabad, or Mumbai. The water and wastewater network in the cities is something that TCE has designed. In the built environment, today we are handling 14 smart cities, about 15 MSMEs, Namami Gange in 5 states we are there. We are into universities, hotels, hospitals. The Sardar Vallabhbhai Patel statue that was inaugurated recently, we are the proof consultants for the government of Gujarat. We are also into port harbors and transportation. In power, we have done 100 gigawatts of coal-fired plants and about 25 gigawatts of gas-fired plants. 85% of the nuclear plants in the country is something that TCE has touched, either working for Department of Atomic Energy, NPCIL, or for contractors. From a renewable perspective, we are into hydro, wind, solar, solar thermal, and PV, biomass, and waste to energy. And we have a team that works on transmission and distribution as well, up to 765 kV, AAS, GAS, HVDC, smart grids, and so on. Under resources, in hydrocarbons and chemical segment, we are in refineries, petrochemicals, food, pharma, and specialty chemicals. And in mining and metallurgy, both ferrous and non-ferrous, geology, mine planning, mine beneficiation is something that TCE is involved with. With this three verticals that you see, we have a horizontal, which is on project management. We have about 1,000 engineers at 130 plus sites across the globe doing project management at the site. Industry 4.0 has made us start a new horizontal, which we call as advanced technologies. And that is something that we started very recently. At any point of time, TC handles about $35 billion of physical infrastructure projects for the country and outside India as well. Our customers are lenders for whom we provide lender engineering services, and owners for whom we provide owner engineering services, and EPC contractors, we do the engineering for them as well. We also work with the GEs and Siemens of the world as their preferred engineering partner. So let's talk a little bit about how Industry 4.0 made us get into these advanced technologies. And what we do in this is about building information modeling, 3D, 4D, 5D, asset digitization or digital asset management, AR, VR, and IT, engineering IT services. And how we started being a 56-year-old organization is that we have to change our culture itself. We have a lot of domain experts who are not so willing to change, and Sal spoke about it a little while ago. So we set up an IoT lab, and it's in our Airoli facility, in which we demonstrate to our customers the various digitization efforts that are underway. And this is not only for customers, but we did this because we needed it for our engineers as well. One of the largest efforts that are currently underway is when you have old existing plants, the services that we're now offering is about doing 3D laser scan of the entire facility and then converting that into a 3D dump model and then building intelligence to it so that a digital asset is there with the customers. Suppose there is a large complex in which you have some, let's say, 12 units, and the most recent 3 units may have a 3D asset. But what about the remaining 9? And that is where this would help. And even these 3 units that have a 3D model may not have everything in an integrated manner in terms of all the documents that you need, whether it's a PNID or a data sheet or a spec of a valve or a pump. Some of the customers may not even want to do this laser scanning. For them, what we are doing is they have a whole lot of documents, right? So these scanned PDFs are not searchable. So we develop templates through which all these documents are available to them on their EDMS at the click of a button based on the hierarchy or genealogy that is suitable for that particular plant. At this point in time, for a large refinery in India, we are doing this. As you can see on the screen. So it's not only about having a 3D model, but also having the entire hierarchy of the documents there. And at the click of a button, while being on the 3D model, you can open it and also get a split view of the actual part as well as the horoscope of the part. And we're using Aviva Engage and Aviva Net for this purpose. And what started as about a million document effort is now into about 6 million in this large complex, which is a refinery complex. We also do for a part of the complex. For example, this is a petrochemical plant in which there was a plan to replace heat exchangers and pipelines and also change the material of these pipelines. So you can see the point cloud data which is obtained from the 3D scans and how the final output is there. But these are not without challenges. Some of the lines will be in between large bore lines and you will not be able to get that, and there are challenges involved on how to get that. And suppose you have some scaffoldings in place, again, getting the right model. So we have written our own scripts which will help us do arrive at this 3D intelligent models. Another example is a revamp of a blast furnace. The challenge here was that the customer did not have the P&ID also. So this was really an old plant. And this is where we believe our 56 years old legacy and the domain expertise helps us. And this is what we believe differentiates us from the rest. Moving from asset digitization into smart cities, as I said, these are the 14 smart cities that are currently underway. We started getting into smart cities way back in 2007-2009 timeframe in the GIFT city in Gujarat. And then the Delhi-Mumbai industrial corridor, we were into 3 of the cities, Dadri, Ghaziabad, Noida in the capital region, Vikram Udyogpuri in Ujjain, and the Dholera industrial township in Ahmedabad. All of these cities that you're seeing are in various stages of development, and the components are, as you can see, smart water, smart wastewater, renewables, energy efficiency, EV charging infrastructure, waste management, solid waste management, smart bins, separation at the source of dry and wet waste. And there are several ICT components like ambient air quality management system, vehicle management, bicycle sharing system, security, and all of them with a central command and control center. The entire thing for these cities are something that has been conceptualized by us, but we work with our technology partners. A small video, but I think I will, can you play it maybe for a while?
Welcome to Bhopal, Madhya Pradesh, the lake city with a beautiful blend of history, culture and modern urban planning. An ambitious area-based redevelopment has been initiated at Tatya Tope Nagar. Smart City Bhopal. 342 acres of government land has been redesigned with planning guidelines of TOD. 2 metro lines and 3 transit nodes impart excellent connectivity and conflict-free exchange between metro, bus and IPT. Network for non-motorized vehicles along with smaller building blocks ensures shortest distances. Interconnected open spaces are spread over 65 acres of ABD master plan that strives to retain existing trees. The social infrastructure envisions supporting 60,000 people over the next 20 years with facilities like health centers, schools, sports complexes, spiritual centers and recreation hubs. Technology-enabled infrastructure integrated with IBMS of green buildings will make the Tatya Tope Nagar smart. 5 character zones are designed over 90 land parcels, Boulevard Street, Commercial Wellness Knowledge Center and Residential Hub. The tree-lined Boulevard Street with a barrier-free design is the development's pride. Well-planned smart parking is provided as on-street, off-street, podium basement and multi-level car parks. The City Command and Control Center will monitor Bhopal's smart infrastructure. Rehabilitation includes vendors, shops, government houses and schools. The green plazas at the transit nodes connect with public open spaces through pedestrian routes. The commercial activities at nodes will thrive on higher footfall and generate additional employment. 2-meter cycle tracks meander through the entire area. Bus stops are equipped with facilities like drinking water, trash bins and ATMs. There are lively activity zones and a variety of pockets for vehicular carts, vendors and food stalls. The DCR ensures active frontages and universal design for the streetscape. The Boulevard Street has a lavish 7-meter wide pedestrian pathway. Dustbins are located every 500 meters. Collection of dry and wet solid waste is enabled by automated solid waste management system. Ducts for utilities like potable water, recycled water, automated solid waste, power and data will facilitate ease of maintenance and prevent digging of roads. The City Command and Control Center will monitor all utilities, traffic, public transport, fire, surveillance and safety by integrating them on a single ICT platform. Intelligent traffic systems allow for prioritizing pedestrians. The UD guidelines bestow Boulevard Street with a 6-meter-high colonnade. The Skyway connects buildings at Transit Node directly to the concourse of Metro Station. Network of non-motorized vehicular routes with small shops and other facilities allow leisurely walk and reduce vehicular traffic. Renewable power as well as rainwater will be harnessed from building rooftops. An iconic building with green landscape stands as a proud sentinel. 11 existing municipal schools will be shifted to new buildings.
I think
these are located
we can stop
close
here. So actually there is, those of you who are involved with smart cities are very much aware what is the current status. And there is an investor meet in Mumbai next week from the SPV, Bhopal SPV, and those who are investors here are welcome to connect with me. I'll connect them to the program manager. So now we'll move from the cities to mines. All of you are aware what happened recently, the tragedy in Brazil. And these tailing dams, the mine tailings are actually the waste that you have after you extract the mineral from the ore. And so every mine will have a huge tailing dam. And there are over 300, 400 instances of tailing dam collapse, which are not only bad for the settlements around, but also environmentally very bad. That is something that every one of us are aware. So in the mines of Joda and Naumonde in Jharkhand state, we are currently working with one of the customers on how we can use I4.0 to monitor the movement of this tailing dam. So what we essentially do is to set up probes at predetermined control points on the profile, and using DGPS, differential GPS, we are able to observe the relative movements, and if you see a change, then immediately the data can be ported onto a finite element model and you do a slope stability analysis and see necessary actions that one needs to take. So this is a project that is underway. On mines, material handling is another of the effort that is currently underway. And I4.0 is very much useful, as most of you are aware, in making our mines safer. Now, if you can just play this small video there. Yeah. Reduce the volume. So, what you see here is a conveyor that takes the ore from the mine to an aluminum refinery, which is 15 kilometers away. And this is a rope conveyor. And so the length of the rope, if you will, is about total 60 kilometers. And maintaining this rope tension is something that is very, very essential. And it goes through valleys and you know, it's a pretty mountainous region, as one can imagine. And so what at where the material is actually loaded, you will see these giant pulleys. And This is actually connected to the conveyor. So this is actually revolving continuously, and that is the rope that is connected to the conveyor. And along with that, there is another pulley which is connected to a giant weight on this tower. So the relative location of the trolley that you see here, which moves depending on the load on the conveyor, as well as the weight that is there, the counterweight that is there, these two dictate what would be the tension in these ropes. So what we are currently doing is a rope tension monitoring system, because the trolley will move to the end, and then automatically there are stop switches, limit switches, which will stop the conveyor from operating, and because the control room is also somewhere else. So we are developing a system using laser positioning, reflector plates, and the necessary electrical works. And from the control room, they are able to see what the actual tension in the rope is, which is also a function of the amount of material that the conveyor has to carry. And once that calibration is done, you will be able to ensure that the conveyor can operate without any hassle. This is a live project underway, and we have also proposed to the same customer the belt health monitoring system through visual analytics. Moving on to metals from mine, this is just an example of a typical steel plant. And the way we work on this is to identify in the process. You will see on the left side, you see the entire process of steel making and all the plants that you will need next to it. And in this entire process, you will have lot of losses, be it electricity, power loss, or water, or steam, heat, flare, gas, lubricant, oil, so on and so forth. And data has always been there. And it is only now that people are opening their eyes to utilize the data. And if I move from a steel to an aluminum smelter, 40% of the power consumption is taken by those spots, it's an electrochemical process. And so how do we ensure that we minimize these losses? That is the thought process, irrespective of which industry, which process plant it is. And this is a typical example of a vibration, which is also faced in many of the industries. And we are working on this problem in a sinter plant, in a steel plant, studying these various characteristics, doing a root cause analysis, which are the dependent variables, which are the independent variables. Do you work in the time domain or the frequency domain? Developing our own tools to separate them, looking at, do we have all the data, or do we need to put additional sensors? This is also work that is underway in Jamshedpur. And the same story continues for the power plants as well. And I'll not go into the details of the losses, but essentially the condenser vacuum and the vacuum pumps, if we are able to do a real-time monitoring, we will be able to enhance the efficiency of the plant by a large amount. And what we have done over the last several years, couple of years, we've developed a boiler performance tool. Boiler has traditionally been an OEM IP, and the plant has to depend, the operating people have to depend on the OEM. So what this does is to predict thermal profiling, including metal temperature, across the entire boiler, right from the furnace to the reheater to the superheater to the economizer. We are able to get this. And we have done this for both subcritical as well as supercritical plants. We have tested this on a 120 megawatt plant, on a 500 megawatt plant, and an 800 megawatt plant. And this is, once you have this, you will be able to tell the operators what needs to be done. Because every day he gets a different call, or he gets call from multiple sources, multiple mines as well. And so it is never the design coal that is there at the plant. Balance of plant, there are various examples, real-time monitoring of the water chemistry, or in a coal stockyard, the spontaneous combustion of the coal. These have huge commercial impacts, and these are some of the things that needs to be taken care. The Power Answer Lab is something that we started about a decade back with IIT Mumbai. This provides Answer is analytical services. So we are able to do short-term and long-term load forecasting, transmission and distribution analytics, wide area management system, and also power exchange. I just have one more minute. This is another example moving from generation to transmission and distribution. For the entire state of Jharkhand, this is a World Bank funded project. We did the entire concept design for grid upgradation. And you see the various technologies there, right from SCADA, because the system is already there, right? So you're upgrading it. So many of the areas do not have SCADA. The energy management system and condition monitoring, drone survey, thermal imaging for the transformers and substations as well. And these are some of the things, and that we did the entire conceptual design as well as the specifications, and now the project is underway. The first, the project is awarded already to the project management consultant. So I will end by telling you what my previous speakers have talked about. So we have collaborate with a lot of people. It is not do it for the customer, but do it with the customer. We have several technology partners, platform providers. We work with academia, various suppliers and government, and also within the group in our own ecosystem. There are various challenges. Both the previous speakers have talked about some of the challenges that I have mentioned. The first speaker spoke about the interoperability, and the culture part was spoken by the next speaker. So both internally and externally, these are something, from our own perspective, we have to move from a services to a solution mindset, from an advisory to an ownership mindset. Because in IoT solution in an operating plant, nobody will come to a consultant until and unless you have the total solution as you are offering. From a maturity perspective, in most of the areas that you have seen, we are in the pilot phase, moving slowly but surely. And process plants are not like discrete manufacturing, right? So, but we are making good progress. And thank you for your patient listening.